Thank you all for coming. This is our monthly meetup for the West Michigan Azure Users Group. And again, we like to always meet on the second Tuesday of the month. We are focused on growing any kind of knowledge and sharing or collaboration around using Azure in your technology solutions. So it's good to see many familiar faces and a couple new faces. It's always cool. We have an excellent guest speaker this month, Randy. We'll introduce himself in a second, but I also want to say that big thank you to OST for hosting, as usual. Kim, thank you. And Matt for emceeing / recording / all the other technology behind the scenes. These meetups are recorded. They're put on our YouTube channel. So if you haven't seen the YouTube channel, please check it out. There's a link to that from the main meetup page. And it's kind of neat. We've got, I think, 5 videos up there now or so. So past sessions, all good stuff. And Randy will be up there as well. So really, that's all. At the end, we'll talk maybe a couple wrap-up things, but I don't want to wait any longer. We'll get started, and I will let Randy please introduce yourself and tell us what you're going to speak about today.
Well, hey, thank you all for coming. Appreciate it. As Brian said, we're going to talk about my topic tonight is Azure IoT. So how many people have played with IoT devices before? Lots. Oh, that's awesome. Specifically, I'm just going to talk about Raspberry Pi, but I didn't bring one clearly. Anyway, I'll introduce myself. My name is Randy Pagels. I work for Xperit. Xperit USA is a consulting firm. We're about a year old in the US. We're US based. We focus on just Azure technologies, app modernization, and DevOps. So we do those 3 things very well. We're part of a parent company, Exebia, which is located in the Netherlands, and they do a lot more consulting and work. So I'm part of that. I'm a DevOps architect there. So I help customers with basically fitting their applications and solutions with best practices around DevOps. That's my role. The presentation style, I'm just going to go through a few slides here to set this up because it's a big topic, a lot of moving parts with this. This is actually a talk I've done as part of a bigger 4-hour lab. So I squished the best I could down into a 30-minute or 60-minute talk. In a nutshell, feel free to connect, reach out, LinkedIn, Twitter, X, whatever we're calling it nowadays. Prior to Xperit, though, I was at Microsoft for 17 years. I've done various roles at Microsoft, from sales to tech specialist. I worked in the Redmond as a program manager on the Azure engineering team for about 2 years. That was great time doing that. So that was me in a nutshell. I've been to this office before. I know Brian from the past as well. The agenda, I'm going to talk a little bit about IoT just to set up IoT itself. Again, level set with the audience. I don't know anybody's experience here, so I'm going to just go to the very beginning. And then talk about a scenario I built as a lab. I'm in the process, actually, right smack dab in the middle of revamping the lab. If anyone's interested in what I'm about to show you to actually work with it yourself and work through the labs, just contact me and I can let you know and email you when it's ready. It's not quite running yet, as you'll see, but it's almost running well enough. So IoT is, in a nutshell, IoT itself, that's an enabling technology. It's allowing the businesses to communicate with customers better. So it's about connecting devices, collecting data, and then that allows to take that data and have more creative insights with that data. In a nutshell, is what this slide's really talking about. It's a big business out there. Look at it, 2025, $80 billion is what they're looking at connecting devices in the future. Keep that short and sweet. It's not just about connecting devices, though. It's more than just connecting devices itself. It's actually about data. So Azure Cloud, Microsoft Azure Cloud, can do a lot more than just collect data. It can help collect information off the devices themselves, process that data. It can help visualize that data. And that's what I'm going to show you, some of those tools that are out there. The other thing I want to say is visualization. It doesn't really say it clearly here, but it's not only in the cloud to visualize that data, but it can actually visualize it where the IoT device resides as well. So they call it edge devices, and that's talking about the intelligent cloud here. This is a reference architecture you can find right smack dab out of the docs. And the idea here is it's 3 things. You'll hear this theme throughout. Things are the devices, insights are processing, and then actions are what you do with the data. So being able to do being creative with that data depends on what you're trying to do. There's probably a million different ways out there, but the whole idea is collect data. What do you wire these devices up to? How do you get that data and process that data and make any sense of it? So my hope today is just to go through some of the basic building blocks of what this looks like, breaking this down. My scenario is going to be, this is more of a data reference architecture, a little boiled down a little bit. The lab uses Visual Studio, use Visual Studio Code, and I have an application that'll run off a Raspberry Pi. I'll simulate that since I don't have a Pi here. You never know about connectivity with those things. But the idea is to have the device move data into the IoT hub. IoT hub is event processing. I'll explain each one of these by themselves. And then through Event Hub, and then there's Azure Functions. Anybody use Azure Functions before? Lots? Okay, awesome. Without Azure Functions, that's the glue. This would not be possible. So I use functions all the time, serverless technology, blob storage, and then visualizing the data. I use a couple more Azure services. Anybody use Azure Maps? That's a good one. Azure Maps, it's a service. I'll show you some of that, the components of that as well. I put this there for fun, but we all know what a Raspberry Pi is. We're good. I haven't played with 4, but 3 is what the lab's done. A IoT hub, in a nutshell, is where you connect your devices. That's the first step. You have a device, a Raspberry Pi. I need to connect it to IoT hub. Very simple. IoT hub is, you can process, the key here is it's bidirectional. So I can actually communicate that. I can upload software back to the Raspberry Pi if I wanted to. But it allows you to communicate with that and processes billions of different transactions per second. So it's pretty awesome. The devices the hub allows secure connection of the devices. And that's just not a Raspberry Pi, just use that as an example. You can connect different devices as well. IoT hub allows you to manage and provision those as well. So I can just start plugging devices in and the hub will manage those. IoT hub, again, large scale, think of billions of devices out there. Lots of examples. I have a couple of real life examples at the end I'll show you. This is a simplified version of what the IoT hub was. It's important to know that IoT hub is the first step. That's the starting point. But I connect my things up to the hub, connect it to a cloud gateway, which is the IoT hub. And then you can use things like application insights. You can use stream analytics. There's different products or services out there. And then as far as doing an action off a piece of data, I'm using Azure Functions. There's different ways to do that as well. So so Azure Event Hub is another streaming service. It's a messaging service inside of Azure, but it also allows you to stream millions of events per second and from any source. One of the sources today I'm going to show is IoT Hub. So I'm going to send data to IoT Hub, let Event Hub grab that data, and then we can transform it and do something with it. But the idea with Event Hub is it's awesome because it does the fan out, fan in model, which looks like this. So just to kind of double click on that a little bit. So Event Hubs, again, this wouldn't be possible without that. The key in this whole slide is talking about the producers, which is the input, which is going to be our IoT Hub. The Event Hub, which has partitions. So think of a partition as I can put my messages in these partitions. And then I have a receiver consumer group. Have as many consumer groups as you like. Consumer group 1, for instance, I can subscribe. A function can subscribe to a consumer group and read those messages off the queue. I can have multiple consumer groups and multiple subscribers to those groups, and you scale it out to hundreds of thousands, and this thing just processes it very well, the Event Hub. I put a little note at the bottom as far as the differences. In a nutshell, IoT hubs allow you to communicate back to the device. Event Hub does not. So if I wanted to run some CI/CD pipeline and update my code running on a device, I would need IoT Hub to do that. I have them both running because it was just too fun not to, right? Azure Functions, a few people said they used them already. In a nutshell, they're serverless. You only pay for what you use. They're tenths of a penny per whatever minute. They're not very expensive. I wrote this in C#. Again, it supports many different languages. Visual Studio proper or Visual Studio Code supports of this as well. So the local development, I can actually iterate over my code and debug it as I'm going, put breakpoints, etc. It's just a great little product to work with. And then I can bind it into different services. Event Hub, IoT Hub, CosmosDB. It's got an awesome way to hook into input and outputs. I'll show you some code. I'll show you a really nifty little shortcut code that I have for this scenario. One of the scenarios you can use, just talking about serverless scenarios in general for functions. Again, this may be more general than not, but again, level set. Serverless technology works really well with, I guess the closest thing I can come up with here, my stream analytics or processing. The ability to actually have the function sit there and listen for stream analytics coming in, and then transform that data and store it in SQL. It's a great opportunity for a function, a bot, processing bot, timer-based. Functions can go off on a certain timer. The functions I'm using today are all event-driven. So anything that happens fires off one of these functions. CosmosDB is what I chose in the background. It was born in the cloud, built in the cloud, runs in the cloud, geo-scalable. It's an awesome database, NoSQL database, for stuffing all kinds of data into it very quickly. So that's what I'm using today to process the events. They get stuffed in there in JSON format. And that's again, it's a great product that's out there if you've played with it. I'm also, just to be clear, usually it's expensive. I'm using the serverless version. So I, like so many of you, probably have a Azure. Who has an Azure subscription, $150 credit per month? Yeah, it goes by fast, doesn't it? You burn through that pretty quickly. I have to constantly shut my services down just to stay within what I can. What I try to. I don't usually do it very well. Good job. Azure Maps is a service we started playing with when I built this lab a while back. There was a couple of us that built this. This was a tricky thing to get working because basically the data that comes in is JSON format. Azure Maps needs it in GeoJSON format in longitude, latitude style. So there's some translation that goes on. So we have another function that does the translation for us on the fly. Azure Maps also, depending on what inputs you get, you can use it for routing, very much like Google Maps. So I can use it for routing, I can show traffic, I can show patterns, I can, that would have helped you tonight. I can go cross time zones. I chose the search and geocoding because the example I'm about to show you uses longitude, latitude. But the map service needs address, like addresses and house numbers, etc. So I'm using longitude, latitude, translating those into house addresses, and then mapping it on the map. So just be clear that Azure Maps has a lot of different functionality. Have to know which API to call to use it. So let's talk about the blue bike scenario. If I would have thought about this at least 45 minutes ago, maybe an hour ago, I would have thought, what does Grand Rapids use? What bikes do you use around here? What's it called? Anybody? The Lime? Is that what it is? Lime? Ride a bike? Okay, same concept. Good. I know every city has these things, but blue bikes is just part of the slide deck. We'll just keep this going. So same concept. You pick up a bike anywhere you want. You ride it around the city and drop it off anywhere you want. It has an IoT device on it. It keeps track of longitude, latitude of the station you picked it up at or the station you dropped it off at or any other location is the idea. That's the backdrop to my demo or lab. This is out of Boston. Same concept as Lime. It's a bike with an IoT device, so you can keep track of that. I went to Boston's website at some point and grabbed a lot of their data to build this lab. And basically the really light architecture of the first piece of this lab, it's a stateless architecture, meaning it's processes on the fly, and when the data is there, I can look at the results afterwards. So same concept as I mentioned before. The code would technically run on a Raspberry Pi and send that data up to IoT Hub. Event Hub listens for it, picks it up, and processes it through a function and stores it in CosmosDB. Now, another function is on the other side of Cosmos has to translate that into GeoJSON, so Azure Maps knows what to do with it. That's what the other function does. And then it displays it on the map in the end. Now, the reason I'm saying it's stateless because that map is displayed when you refresh the screen. I thought it would be so awesome to have it use, use something more like, well, I'm drawing a blank on the function, more real time. But the other piece is you can actually add a few components to it, like use Databricks and Power BI to visualize that data. The data's there, it just matters how you want to see it. Again, just keep that in mind as you go forward. Let's go. I'll look at a few things, and then I want to show you talk about a couple examples of real life examples. Where is the code? Here, let me go like this so I can get it a little bigger here. Again, no Raspberry Pi today. This code is .NET Core 6. I just upgraded it. It can run on a Pi. I'm running it in a simulated device to pretend. So we're all going to pretend there's a device running it. But the idea is, in a nutshell, it's just going to connect. And I'll show you where that looks, what that looks like in the IoT Hub. How do I connect my device up to IoT Hub? That's where it all starts. And when it's running, it'll look like this. Again, this is data I got from the Boston Blue Bikes company. It's data that was off IoT, off their IoT devices. And what it's doing now is just simulating sending it up to the hub, up to IoT. That's what it's doing right now. And I purposely put a pause in there just for, by the time I explain this and walk through it, it doesn't blast it in there so fast that, you know, it does the millions a second. I don't need a millions a second to show this off. But we'll let that run for just a bit here while I go off and show you another thing here. I'm sort of want to just hop around a little bit. One of the functions is, can you guys see that okay, by the way? I know you're not right in front of the TV, but I'm going to show you this in Azure as well. One of the functions here is the Event Hub trigger. It's listening for events in IoT Hub. And funnily enough, this is the, let me see if I can do this. I'll just explain it. It's listening for an event coming in from Event Hub. It's transforming it as an output document to CosmosDB with one line of code, basically, line 16. And that, it's actually an amazing, it's an Azure Function thing. It's not a Randy thing. It's an Azure Function thing to be able to take a data, transform it in one line of code and output it to a CosmosDB document in this format. And it automatically converts it to JSON. So I thought that was just ingenious for the function, not Randy, but for the function to do that was pretty cool. So it just saved a lot of looping and it saved a lot of record creation and stuffing that into Azure. But this is basically start time, stop time, station ID, longitude, latitude, et cetera, et cetera. Notice there's bike ID, et cetera, but notice there's no addresses on there. So if I want to map where someone actually picked the bike up, like to add an address, that all has to be translated. So there's another function, and I'll show you where these functions plug in, by the way, eventually. This is another function that's running that basically, in a nutshell, it picks up the longitude, latitude out of CosmosDB, and maybe it's this one. Yeah, it's this one. It picks up, here, I'll just go, it picks up each record. It's called trip data. So it picks up an actual entry out of the CosmosDB, loops through it, and then converts it to the GeoJSON that it needs. On the fly while it maps, calls Azure Maps. Again, hard to follow looking at it like this, especially from over there, but I have links to the code and links to the examples, but we'll see what it actually looks like here. I think that's all I want to show you at the moment. Let's go back to, let's go in here. You probably have to up this a little bit. So the first thing I'll show you is IoT Hub. So when you set up an IoT Hub, you know what? I do want to show you this actually. This link. So this is a workshop. Again, this is what I'm working on right now. If anybody's interested in doing this, you can actually build one of these from scratch. I assume you have a raw, you know, a brand new Raspberry Pi in your hand, all the way out to map data generation. But that's what this is. This actually walks through setting everything up. I'm not going to go through it right now, but this walks through looking at the lab, setting it up, how to get the code onto it, how to view it, how to compile it, run it, etc. This walks you through step by step, and that's what this is right now. And so let's go over here. So this is the IoT Hub that when you walk through the lab, it'll say, like, hey, set up this IoT Hub. A couple things I want to show you is setting up a device. So it's as easy as saying add a device. Again, probably can't see that very well. That's okay. We'll go 175. If I say add a device, You give it the name of the device. So I would call it Raspberry Pi 3, Raspberry Pi 4, whatever your name of your device is. You put it in here, and it'll basically give me a connection string. It gives me a nice, unique ID. And the unique ID is what I use on the Raspberry Pi so it knows where to send the data. It's just a quick connection. I already have a device sitting here. We call it Raspberry Pi Detroit 1. The primary key is what you'll need in the code. The code comes basically when you install or look at this code, it'll just say, hey, give me the primary connection string of that device. So it's pretty straightforward. The other thing you need to know is routing. So when I get a message into IoT Hub, where do I route it? And there's different routes here, but if I say a custom endpoint, you'll notice, again, I can't zoom in here, but let's go like this. The key is I'm routing it to an event hub. So it's doing it on the fly. So if I were to check any one of these, let's go back and look at it right now, because that thing's been running. If I look at the last hour. Also important to know, depending on what, everything in Azure, as we know, has a different cost to it. So this is like I believe this is a standard IoT hub. I can actually have 400,000 messages daily, and then it stops. I've only used 2,800 so far, so I'm probably good. Well, we won't have enough time in this user group before I run out, which is good. Now remember, there's always a little bit of delay sending data to Azure with the IoT hub. It's there, it's processing it. You can see it's at 3.19 thousand messages when I first started this. But if I zoom in here, you can see it's actually running. That says 3,000. You probably can't quite read it, but that's what it says. The other piece I want to show you is the event hub itself. Let's go look at that. So a couple things. The event hub itself, I click on event hub. Actually, I wanted to go here. So as soon as I started sending data to IoT Hub, Event Hub's picking it up. It's showing me it's picking it up. And there's a function running right now listening for that event, which does the processing, and it transforms that into JSON and puts it into CosmosDB. And then that's where the processing works. What is key here is, if I go to down in here to the Event Hub itself, I have an Event Hub called a Hubway, which is what the blue bikes is, Hubway telemetry. So I click on that. Now I'm actually looking at one of the partitions. And in the partition, I can see there's two consumer groups. Remember, if you subscribe to a consumer group, I can get just those messages. Someone else can subscribe to another consumer group and get those messages. So those messages I call Hubway consumer group. That's important because I want the maps to draw off a consumer group, not just all the data, because this way you can filter out the noise. If you don't want the blue bikes, we want the line bikes, I could have a consumer group for just those bikes. So you can process this a lot in a lot of different ways. So anyway, you can see the data's coming in here. Let's go look at the functions. I think that's next. Yeah, let's look at the functions. So if you've played with Azure Functions recently, you'll notice that the UI changed when I was redoing the lab. And I'm using Functions version 4, which is .NET 6. If I look at the very first one would be the Event Hub trigger. This is the first one, the function that runs is listening for IoT Hub. And if I go to monitor, so this is what's running. Now I will, in all transparency here, tell you that it's complaining about a binding with a null reference. So I will say it's running, but it's got a problem with something. That's what I was saying. I was transferring this. So complete honesty, this is not running successfully, but it is running. So therefore, it's not pushing that data into Cosmos because it stops with a null reference error. So I have to check. I've been meaning to check. I'm not meaning, but I'm working on checking on this. I just couldn't figure it out fast enough. So let's go back. What's cool is, anybody using Application Insights out there? Yeah, a few. What's cool is I can actually go back to my Functions app, and there's a few other functions here. One of the function reads that data from IoT Hub to Event Hub. The other function will actually process the data in CosmosDB and execute it. I put together some screenshots of what you'll see when this works. I want to show you that as well. What else would I show you here? What's interesting with Application Insights, of course, it's listening for the function. So my plan is to go debug this through Application Insights, which I thought was pretty awesome for failures. So that is a good thing. CosmosDB, let me show you that, where it goes. So in CosmosDB, there's a collection called trip data. And inside there, you'll find items. And this is where all the JSON would normally go if that function is working properly without a null reference issue. The reason I'm showing you that is because that's part of the setup. So when you think about it, you set up this basically the data services. You're setting up an IoT hub. It's got primary key connection strings. You're setting up an event hub. You're setting up Azure Maps with its own keys. You're setting up a CosmosDB and the databases that go with that. And then you're setting up all the functions that have to have all those keys and connection strings to work correctly. So it sounds like a lot of work. The labs are usually a couple hours to do all that. And last, I want to show you, who's using Key Vault today? Awesome. Awesome. Show you a couple things in Key Vault. So I've set the new labs up to use Key Vault. Key Vault's where I store the functions storage key, it's blob storage, the maps key, the maps client ID, the connection to Cosmos, the connection to Event Hub. Again, just good best practices to do that. The way the labs are written today are not that way. They're stored in the JSON local file. And we all know what happens when you check that into code, or into the repos. If you're in GitHub, you hear about it really quickly. So anyway, this is the best practice to do it. Store these things inside of encrypt them inside of Key Vault. What I wanted to show you that where I'm working on is this. Let me go like this. So part of my rewrite of the labs is, instead of doing the labs manually, which you can still do for someone new to this, can teach themselves this. But if you want to just play with this, I've built a pipeline that will create every resource you need, including all the keys and connection strings, and deploy that as infrastructure. So it's infrastructure as code. And then once the infrastructure is deployed in Azure, basically all I need to do is tell it what resource group I want, and it'll create everything for me, and then lock it when it's done. I actually add devices as well. So I add a device automatically, grab its connection string, stuff it into, or update the function that needs it, or update the hub, the HTML that needs it, which gets stored in blob storage. So this pipeline will do all that for you. So everything I was showing you, again, it's an automatic thing. It's almost bug-free. Who doesn't like that? Almost. Almost. So this pipeline actually built what I showed you tonight. So it did it in 9 minutes. Again, it would take you at least 2 hours to do all that manually. So anyway, I'm a big fan of infrastructure as code, as you can see. I plan on updating the labs here, which are back at this, as I showed you the page. These labs here will be path A, you can go through the labs manually, or path B, hit go, hit pipeline button and let the GitHub Actions run and do it that way. I'm going to show you, let's go back to slides. I think I'm showed everything I wanted to show you. Because I do have some screenshots. I've been doing demos long enough to know that sometimes they don't work. You need to show what you're going to, or what you should show. Let me actually zoom forward. Let me zoom forward here, and I'll come back. So the IoT hub will process the messages. There's the 400,000 and 1,300 coming in. Again, this will just run across as you're running an IoT hub. Running my simulation with a slower, 1 every 5 seconds, takes a lot of data to move the needle, is what I'm trying to say here. Event hub will start processing the events that come off IoT hub, and a function will get triggered off, which is what this hubway HTTP trigger is. So the function will run, and you'll see the data as it's processing as well. And the idea now is take Azure Maps, which I embedded into an HTML file. The HTML file has the Azure Maps key, which again is in Key Vault. It goes and gets the key, and then it fires another function to take the JSON data out of Cosmos, translate it into they call it GeoJSON, so that Maps knows what to do with it. Now with Azure Maps, there's many different ways to present that data. I chose the bubble chart as well. And I'll show you the bubble chart in a second. This is just showing that there's a bunch of JSON data here. And this is what ultimately the end would look like, is Azure Maps plotting the pickup and drop-off locations of a bike. And you can see the more populated areas, downtown Boston versus out in the suburbs or a little further out. But the idea is taking that data, and there's hundreds of thousands of records of data that's being processed here. We thought it would be cool to say how many events are at this location versus that location versus this location. We could have taken this data also and with Maps drew the start and end location and the actual path that it took. We thought bubble would be cooler. Again, you can do, there's probably 1,000 different ways to do this, but this is what we decided to do. Show me the bubble size. So we thought as an enhancement, like a roadmap enhancement, we thought it'd be really cool to take the data as it was processing. Again, you can do it in real time with Stream Analytics, or we thought we'd use SignalR to actually draw the map in real time as the data was processing too. I thought that would have been cool. So there's some ways, you can actually different ways to go here if you wanted to do it that way. But this is what it looks like in the end. Let me go back. So a couple of real life scenarios. Not that that wasn't. I mean, that was using real IoT data off real bikes. It'd be interesting to do that with Grand Rapids data. One of the examples, is Gojo, and we use Gojo machines, hand sanitizers. No, come on, Gojo. So what is this problem trying to solve? Gojo, hospital infections. 75,000 people die per year of hospital infections. Pretty much nutshells, people aren't washing their hands very much. This is real life. You can Google this with Bing and find this information. But the healthcare system, again, it's costing healthcare systems $35 billion a year. So the answer here, and this was a prototype, it's in many hospitals now actually, is the Gojo machines have IoT sensors in them. And they're deployed throughout different hospitals, 100 different healthcare facilities with these Gojo machines that are dispensing hand sanitizer, and it's keeping track of that. This system runs on Azure using basically Azure DevOps pipelines, Azure Visual Studio to build. It's running on IoT Hub and Event Hub using Stream Analytics so they can actually monitor the Gojo machines throughout the different hospitals. This is real life situation. This one's cool too. The mining loaders, those very large loaders in mines. This is a very large company using this machine. They're $10 million each. These tires on these machines are 8 foot tall. They're 500,000 pounds a piece. The two use cases, equipment parts. The equipment's basically selling equipment parts is where they make most of their money. So there's IoT devices on the equipment parts themselves to detect when they're wearing out. And they can be proactive in replacing parts before they break. less expensive to replace the part before it breaks something else. So there's IoT devices on these parts. The other thing is this equipment insights, this articulated face engagement detection. Who's going to say that 3 times fast? This is the strain when the loaders go to pick up a load of core, a load of dirt, or a load of whatever. If the buckets aren't quite in the right position, a lot of damage happens to the hinges. So there's IoT devices on these buckets now to detect the angle at which they go into and pick up these loads. And this is processed in real time and displayed for the driver in real time on their display to make sure the angle is exactly how it's supposed to be so it doesn't wear out the articulated face of this bucket. Now that used to take 18 hours to process that data post. So they're doing all kinds of damage on these buckets without even knowing it. So that's another thing that's going on right now. So they're examining this data in real time. This thing is a factory on wheels. You look at that data on the right-hand side here. It's using IoT, IoT Edge. It's using event hubs to collect this, all the different data here. There's about 300 or 400 sensors on these machines. 1,500 pieces, pieces of data per second. They're processing as this machine's running. There's 3 or 4 Ethernet Ethernets on this thing, and these IoT devices are under the seat basically. So again, I call it a factory on wheels. It's a pretty cool. So these are real life. The last example I'll show you is mining. So hydrocarbon exploration, drilling mine or wells that are drilling. One of the examples is the drilling heads themselves. Extremely expensive when those heads break. High speed, they're drilling. So what this company did, these are companies I worked with, by the way, in the past. What this company did was put the IoT devices on the heads of these drilling machines so they can detect when they're overheating and they can stop the drilling so they don't break or break off. That's huge cost savings because replacing the heads, not only the head itself is expensive, the downtime for the crew that was working it has to basically not work, and that costs the company a lot of money. The other thing, it takes a lot of water to cool off these machines. So knowing where the water trucks are, GPS located, data driven, how many trucks are we going to need for the site? They can detect all this information. They're using Databricks. They're using a couple other pieces here, IoT Hub again, event hubs. Stream Analytics are doing this in real time. They're doing Databricks to process all this data as well. And then blob storage. They're using actually Azure DevOps pipelines and YAML to basically build and deploy their applications out to their IoT devices. And then they chose to use Power BI to visualize their data as well. So they're not using Maps like I did. But that's another example there. So I thought that was pretty cool. What else do I have here? I just put some links in the slide deck basically to allow, if you ever wanted to go play with this stuff, my GitHub repo where I'm in the middle of transitioning that and building out that pipeline. That's the very first link. I know you can't read it at this point, but that's what that link is. And I think that's all I have. I did the screenshots are in here. Yeah, that's it. Questions or conversations or comments or anybody else with cool IoT stories?
I'm curious to hear what are the top 3 most expensive services in the architecture?
The 3 most,
expensive.
The most expensive services in that architecture?
I guess it's probably like
Stream
Stream Analytics or
Analytics is expensive. Databricks. I didn't use either one. Part of that was keep the costs down. Again, I used to have a lot of tons of Azure credits. I don't anymore. I use $150 a month now. It used to be $2,500 a month. Big difference. But this lab, again, I worked with another data and AI guy from Microsoft. We worked on this for a while. We chose not to make it overly complicated as well. Putting Stream Analytics in there and Databricks, and Power BI, it was extra things we didn't want to do. So, but those would be the 2 biggest for sure. CosmosDB used to be expensive. I don't believe it that much now. I've been running this lab for a few days, and it's maybe cost me $4 or $5 at most. This thing's been running, this rig, if you call it, has been running a while. It's not expensive. So Cosmos used to be, but that's it. The functions only run, actually it's cheap because it's not running at all. It's broke. So my function's not running at all. It's not costing me anything. I'm not using SQL purposely because SQL, even the lowest cost for a developer would be, it's like the minimum I could probably squeeze out of this was $10 a day. So that's why we chose CosmosDB again. We chose these components purposely. Yeah. Yep. Learning, I'm sorry.
Alerting, like.
Oh, alerting, yeah.
Hook into some kind of alerts or.
So it depends on what you want an alert on. You can hook into alerts. Azure itself has lots of different alerts. In fact, there is an alert setup right now. So for instance, application insights can alerts on failures or exceptions if you want. The message hubs can set in alerts. Azure's just built in with monitoring and alerts all over the place. It just depends what you want to do. If you want to get an email or a text message sent, you can do that easily. Yeah. But it's an alert on, if you pick something in an alert on, we can set it up. Yeah. You can get all kinds of alerts. Even when your function breaks. I can have Azure App Insights send me a text or a group, whatever. I turn all that off. It's got too noisy. Yeah?
What about scale? This is a good demonstration of the possibility of these particular components.
Yeah.
Would you choose different components with you guys?
So scale is interesting. Again, the hubs themselves are processing millions of messages per second. The same exact hub that I showed you. So I'm going to say there's not any difference. There really isn't. With one exception. I'd have to look it up, but I'm using Azure Functions, which is the glue between the messages and Cosmos. I'm using a serverless version. It will scale pretty fast, pretty well. There's also a premium version of Functions that's always hot, and they can process a lot more messages. But in a real life scenario, they're using Azure Functions. The 3 examples I showed you are using straight up Azure Functions, not premium. Premium costs more. Premium is always running. Yeah.
Question: with the IoT hub and the Raspberry Pi in this situation, is that a persistent connection that it makes with that? And does it use that persistent connection, or does it every time it's got a message establish that communication?
The connection, I believe, last I checked, was persistent. However, there's a timeout period. As long as it's sending messages, like right now, I never stopped that. It's probably still sending messages. It'll stay connected, but if I stop, yeah, it's still going.
Would that create a difference in scale then? If it's not hammering it, with setting up a connection each time, it's got a message.
Yeah.
Versus, and maybe this situation is a little different. I don't know how often it needs to communicate.
It is not setting up a new connection every time. That's established, again, how you write your code, right? The code hits the connection once and then I loop. It's also, I guess you could have bad coding. You could set up a connection each and every time in the loop. That's just a bad idea. But Azure sees that device. Right now it's connected. It's connected to my laptop thinking it's a device. It's not. Because I'm using a device connection string. And there's different settings with that as well. Yeah. Should probably stop this now. There we go. Any other comments or input or? Yeah. Yep.
Bottom of that slide, it mentioned underneath roadmap, improved security, Azure Sphere.
Azure Sphere device.
Insight for that? That's kind of a new one for me.
Yeah, I don't have a lot of or any actually experience. Azure Sphere is a secure device, an IoT device that came out. I don't know much about that, but it has a like a security chip on it. Back when I put the slide together, that was where they're going. It might be there not by now, but it was a secure, so you couldn't hack into the contents of the IoT device itself. Sphere is a pretty.
Is that a concern if you're going to do something like this, like the security of the transmission of data?
I would say so. Yeah, you don't want to falsify data, and there's hackers out there that would, right? Yeah, on something like this, especially.
And then another thing, you talked about GitHub Actions pipelines, CSCD. Out of curiosity, which type of infrastructure as code are you using? Like ARM, Bicep, Terraform?
So infrastructure as code, I'm, again, a big fan of. I'm using Bicep, which if you've used Bicep, compiles down to ARM. Yeah, in a nutshell, I'm using ARM. I'm going to Azure, I'm using ARM. I know Terraform's big, it's popular out there. I always think if you're going to Azure, again, my personal opinion, go to use Bicep, something easy to code in. The more you use it, the more I like it.
I know setup.
And,
Terraform has.
and there's no setup and there's no state file to maintain. When I code in Visual Studio Code against an Azure API, I get all the IntelliSense with all the options immediately. It's instantly. It really works well, and then I modularize everything. So even this demo, it's like, what do I need? I need this, I need that. I put all the, I actually usually stand up the infrastructure first before I even deploy an application. So, and then the deployment pipeline just deploys. I do is everything I can possibly do in Bicep. Now, the only thing I couldn't do tonight, just in this example, in Bicep, and I'm finding these little nooks and crannies of Bicep, or actually ARM, I can't add a device to an IoT hub that's out there and pull back its connection string through Bicep, so I had to use Azure CLI. But no big deal. No biggie, I throw it in the pipeline. And then, yeah, the Azure Functions just pick up. Yeah, so even the functions, everything you saw that's running in Azure is built from scratch. I delete that resource group and I can hit run, and 9 minutes later I have the complete infrastructure set up, complete with keys, using managed identity so the services talk to each other. It's, again, best practice security. So anyway, it's a long-winded story to I like Bicep. Anybody else use Bicep?
We had a previous session.
Oh, you did? Okay.
It's done very well.
I've seen some sessions before at conferences on Bicep, Terraform. I mean, and customers I've always worked with it when I was at Microsoft always used Terraform. So Bicep is used out there. I haven't seen it, found it yet. I use it. Yeah. Again, and that's another thing. Speaking of standing things up, again, I'm limited, as many of us are, to $150 worth of credit. I have a few other demos that use a lot of services as well. I converted all of them to use Bicep pipelines. So when it comes time to, like this, if I do this another month from now, let's say, of course it'll be working by then, but let's say I do that, I'll delete the resource group tonight, and I'll just stand it up again tomorrow. I have one called Mercury Health. That's another, probably twice the number of services here. And again, it just stands it up. I think that's, another, whatever, 10 minutes. Yeah, point is I stand up the services, I need them and break it down. And that's doing like UI testing, it's doing load testing, it's doing many different things, and all the reports get written out to like GitHub pages so I can actually look at the reports, which is nice. Now I can just tear down the infrastructure. I don't need it anymore. It just seems, conversation-wise, but it just seems like a lot. There's customers out there that stand up and maintain a dev and a QA and a UAT environment, and they deploy, and those things just keep on running. It's costing money. So again, I don't, if the sole purpose of that is for testing, do all your tests, store off the data, and then tear down that environment. So, anyway.
One last hard question. So you have all the experience, you've shown us this, you're working with it in the real world. What's one thing you would tell yourself 3 or 4 years ago about this that you learned along the way that was maybe something that would save you time?
In this specific example, IoT?
Yeah.
What would I tell my younger self? Come on, Brian. Oh, we're out of time. We're out of time. What would I tell my younger? Well, I don't know, because I'm rebuilding the lab now in .NET 6. I'm going to put it, by the time it's done, it'll be .NET 8. It'll be launched next month. Or sorry, November, my bad. .NET 8 will be LTS by next November. What would I do differently? Because I don't know what I would do. I don't think anything, actually. I'm using cherry-picked every service here to make sure they all work well together. I've always wanted to make this deployable, but again, it defeats the purpose. The whole purpose of the lab was, have customers come in and sit down and walk through and get to play with their Raspberry Pi and make it light up. That was the whole point of the lab. And if you deploy that in 9 minutes, the fun's gone. Now you can still have pizza and stuff, but it's not the same. But I've always wanted to convert that to a pipeline. That was 5 years ago. So I almost have that pipeline's about 80% done to make it just flawlessly deploy. Good question, though. Anybody else? What would you tell your younger self about this conversation? If you could go back an hour ago, what did you say, Randy? Show us what? What didn't I show, or what did I show? Constructive feedback is welcomed. Besides a working copy of it.
Yeah, I might be curious to see Dataverse a little bit more. Talk about the lab. Just curious about
And I'll say it. Yep. The guy I worked with on this is a data. He was a data and AI expert. He did the Databricks piece. I don't know much about Databricks. Yeah, we never even actually incorporated it anyway. Databricks was used on a project for the mining company. He was doing the Databricks piece there. So if you had specific questions, email me.
Does he want to speak at the West Michigan Azure User?
If it's remote.
Maybe.
He doesn't live around here, but if it's remote, do you do remote sessions? Not so much.
Kind of. We put one kind of. That was a while ago. That was maybe last year.
Okay, they're a little more difficult. Yeah. Anyway, pipelines of the future. Infrastructure as code. Anybody else using Terraform? Yeah. For yourself or customers or all the above? Same diff. Customers, yeah. Some of the large customers I've worked with were all Terraform. They only deployed to Azure, but they were all Terraform. So I didn't quite understand that. Someday someone will explain that to me.
Probably just to get away from using ARM before Bicep was released years back.
Probably. ARM is not easy.
Yeah.
Not easy. It gets messy really fast. Yeah, I guess that's where I crossed over into starting to use Bicep for everything. I did a lot of demos for customers, and I put together a lot of different things. This is just probably one of 6 different sets of demos. And I always thought to my younger self, man, make this into an automated pipeline. So when I can do a demo tomorrow, I can run the pipeline today, and it's all stood up for me. All the configuration and setting up the keys and the connection strings and all that is just done. Big fan. Yeah. I created one service principal that my pipelines use. I gave it godlike rights to my account. Why not? And then let it create the resource groups and all the resources and write. When you're writing keys into Key Vault, I mean, you have to have some rights to do that, let alone view the secrets once they're there. So I finally figured that out. Create a good service principal. Better than full access. So anyway, that's besides the point. So how many people here are doing, using the actual product Azure DevOps? I'm curious. Okay, how about GitHub? GitHub, both, a little bit? GitHub Actions or yeah, a little bit. More than just repos? Like issues and branch protections and actions and, okay. Just curious.
Awesome. Well, thank you very much.
Yeah, you're welcome. Thank you.